So this is R2 assignment from Math 114 or Math 214. So these are the prep assignments. Anyways, we want to find out what the answer to this problem is. You have to use PEMDAS. They have the same hierarchy, and A and S have the same hierarchy. Multiplication and division have the same hierarchy, whichever comes first from left to right. The same for addition and subtraction. Parentheses is first, then exponent, then multiplication or division, addition or subtraction. So we want to find out what the answer to that is first. We have to look for parentheses. There are none. So then we look at we look for exponents. There is 1. We have 4 to the power 2. That means 4 times 4, guys, not 4 times 2 is 4 times 4, which is 16. So we have 8 plus 16 divided by 2. Then we have done the exponent. We didn't have any parentheses. Then we say, do we have any multiplication or division? We do have a division, so we have to do that one first. So 16 divided by 2 is 8. 8 and 8 is 16. So the answer is 16. When we have a fraction being raised to the power 2 is no different. That means multiply what is inside the parentheses by itself twice. If this is a 3, we write 3 8 9. So top, bottom. 8 times 8 is 64. 9 times 9 is 81, and you can't reduce this anyway. This means multiply negative 2 by itself 3 times. This means only multiply 4 by itself 3 times and carry the negative. So negative times negative is positive 4. 4 times negative 2 is negative 8. Here 4 times 4 is 16. 16 times 4 is 64, and then we have the negative. This problem, the negative is outside, so you multiply 5/2 by 5/2, then you carry that negative. 5 times 5 is 25, 2 times 2 is 4, you put the negative. What about this problem? This problem, you have 5 being raised to the power 3, not 2. If you had 5 over 2 to the power 3, this means 5/2, 5/2, 5/2. But right now 3 is over 5 only. So you have 5 times 5 times 5, you only have 1 2. So this is 5 times 5 is 125. 125 times 5 is 625. So that is your answer. Whereas this one, I'm sorry. I don't know why I wrote that. 5 times 5 is 25. 25 times 5 is 125. But now here 5 times 5 is 25. 25 times 5 is 125. 2 times 2 is 4. 4 times 2 is 8. So that would be the answer to this one versus this problem. In this case, you have a subtraction sign. So this problem becomes either addition or subtraction. It doesn't become multiplication. So negative and negative turns that into an addition. And then you have 5 times 8. PEMDAS says do your multiplication first, then add. 5 times 8 is 40. Then you add 5, you get 45. So negative and negative turns this problem here to addition. But since you have a multiplication, make sure you multiply first, then add. In this example, you have negative 4 over 2 to the power 2. If you notice, negative 4 over 2 is negative 2. So negative 4 over 2 is negative 2. Then you just have negative 2 to the power 2, which is negative 2 times negative 2. The answer is 4. So the answer to this piece is 4. And then you have to find the answer to this piece. This 3 only belongs to 4. So you have 4 times 4 times 4. That gives you 64. You have a negative sign. This negative and negative becomes, no. の。 Sorry, that negative is gone. I can't multiply this negative by this negative because I have to do the exponent first. So I have negative 4/2 times negative 4/2, or you can write this as a negative 2 to the power 2. So negative 4 times negative 4 is positive 16. 2 times 2 is 4. 16 divided by 4 is 4. As I said, you can write this as negative 2 squared, which is also positive 4. So that's a positive 4. Then I carry the negative. So I have a negative 4, negative 64, and negative 4. I add these two, I get negative 68. I add these two because I have a negative and a negative. I borrow and borrow. I get negative 72. You add the two negative numbers. And here you add the two negative numbers. This is an equation. Now we have an equation, and we have to solve the equation. So to solve the equation, you want to isolate your variable. Right now, I want to isolate this u. I want to have u by itself. So how do I solve equations? Sometimes you can solve equations using this PEMDAS, only going backward. So in this case, you say, do I have a subtraction? Yes, you have a subtraction with respect to your unknown. So do the opposite, and the opposite of subtraction, you add a 6 to both sides. You have minus 7 plus 6. So you have borrowed 7, you return 6, you still owe 1. 7 take away 6 is 1, minus 7 plus 6 is negative 1. Negative 6 plus 6 is 0, you just get u. So u is isolated, u is by itself, so u is negative 1. So what are you saying? You're saying that if I substitute negative 1 for u, negative 1 and negative 6 gives me negative 7. You're looking for a u that makes this side negative 7. So negative 1 is the answer. I want to isolate w. To isolate w, I have a division. What is opposite of division? Multiplication. So I multiply this side by 4, and I multiply this side by 4. So what happens when I multiply this side by 4? This 4 and 4 cancel each other. I get a w by itself. 4 times 2 is 8. 4 times 7 is 28. The answer is 288. In other words, if I put 288 for w, and divided by 4, I will get 72. Again, I'm solving for u, and I have a negative that I wanted to go away, and I have a 3 that I wanted to go away. So what is opposite of division? Opposite of division is multiplication. So when I multiply by 3, these are gone, but I want this negative to go away. So how about if I multiply by negative 3? Whatever you do to this side, you must do it to the other side. So you multiply the other side also by negative 3. So you always figure out what to do to get u isolated. So opposite of division is multiplication. You want to get rid of that 3, multiply by 3. But then you're left with a negative. To get rid of that negative as well, multiply by negative 3, because negative and negative becomes positive. 3 and 3 are gone, you get u. Negative times negative is positive. 3 times 4 is 12. 3 times 2 is 6, and 1 is 7. So the answer is 72. So let's see what other things. The next thing you need to understand is the following rule. If you are multiplying something like that, x is a variable, has a 3 exponent, x is a variable, has a 2 exponent, and they're being multiplied. Since you have x and x, you add these exponents, and you write it as 3 plus 2 is x to the power 5. So if I have x to the power 3 times y to the power 3, I can't multiply them because this is letter x and this is letter y. But if they're the same letters, if this is a y, then I can write one y and add these 2, 3, and 3, I get 6. That's one of the rules. What if I have y to the power 3 plus y to the power 2? I don't have a rule for that. I said if it's a multiplication, that is the rule. And then there's another rule. That rule says if you have x to the power 3 to the power 2, then you multiply these two. You go 3 times 2 is 6. It's called the power rule. You have a power and then you have another power. You multiply these two powers. We have another rule for division. If I have x to the power 3, or let's say change that to 8, and then I have an x to the power 5, I go 8, which is bigger, take away 5, I get x to the power 3. But what if 5 was on the top, 8 is on the bottom? Then I perform the subtraction on the bottom. I have an x and an x. I get x 8 take away 5 is positive 3, and then I put a 1 here. If I have the bigger one on the top, I put a 1 here, but when you have a 1 in the denominator, you don't have to write it. So that's the answer. If you have x to the power minus 2, you can write it as 1 over x to the power positive 2. So when you have a negative exponent, all you have to do is move this entirely to the bottom and make it a positive. So let's practice these rules before I go on with another. I want to mention 2 more rules. If I have any number to the power 0, x to the power 0, 1/5 to the power 0, the answer to all of them is 1. So any number to power 0 is 1. If I have a number, if I have 7 over 9 to the power negative 2, there is a rule here. It says if you have a negative exponent, flip this. So write it as 9 over 7 and make that a positive 2. Now you can find the answer. 9 times 9, that's what you have. You have 9 7 times 9 7. 9 times 9, 7 times 7. And that is your answer. So let me go over some example from your homework. Let's say these rules hold if you have numbers. If you have 2 to the power 3, 2 to the power 2, since there's a multiplication and they both have 2 as their base, you add up the exponents, you write it as 2 to the power 5. 2 times 2 times 2 times 2 times 2, that's 4. That's another 4. That's 16. So you get 32. So what if you have 2n to the power 4? This means you have 2n times 2n times 2n times 2n. So 2 times 2 times 2 times 2 is 16. You have n. They all have one exponent, remember? If I have n to the power 1 times n to the power 1 times n to the power 1 times n to the power 1, I write n, and then I add up the exponents. I get n to the power 4. Another rule to look at, I told you is power rule. You multiply 4 by 1, you multiply 4 by that 1. So you get 2 to the power 4, n to the power 4. So the answer is going to be 2 to the power 4 is 16. 2 times 2 times 2 times 2, that's 4. That's 4. That's 16, n to the power 4. What if you have x to the power 3 to the power 5? You multiply 3 by 5, you write it as 15. What if you have 2 to the power 2 to the power 4? You multiply 2 by 4, you write it as 2 to the power 8. What if you have x to the power 7 and x to the power 4? I told you, because the top one is bigger than the bottom one, you go 7, take away 4, you get x to the power 3. What if you have this? 7 is on the bottom, is bigger, You go 7, take away 4 is 3. So you write it as 1 over x to the power 3. Let's do another problem. We have 4x to the power 5, 36x to the power 1. 4 and 36 can be reduced. 4 goes to 4 one time, 4 goes to 36 9 times. But we do the same thing for the x's as above. We go 5, take away 1 is 4. So we get x to the power 4. But on the bottom, we have the 9. So the answer is that, or you could write it as 1 over 9 x to the power 4. These are the same thing. You would put the 1 here, but when you have a 1 next to your x or next to your variable like that, you don't need to write it. Or you could write it as 1/9 of x to the power 4. What if you have negative 7 to the power 0? That's 1. What if you have negative 7 to the power 0? The answer is negative 1, because that's 1. Any number to power 0 is 1, but then this negative gets carried over. What if you have 2 over 3 to the power 0? The answer is 1. We don't want to have negative exponents. What do we do with negative exponents? So if I have 5 to the power minus 2, I write it as 1 over whatever this 5 is to the power positive 2. What if I have negative 5 to the power negative 2? Again, I don't want to have the negative 2. To get rid of that negative, I write it as 1 over negative 5. I don't mess around with this negative. I only don't want this negative. So that's what I do. The answer to this one is 5 times 5 is 25. The answer to this one is negative 5 times negative 5 is also 25. What if I have 7 over 9 to the power negative 2? When you have a negative here, let me just change this because I did an example like that. Let me just change it to, for instance, 3 and 4. So what do I do with this problem? I flip the fraction and I change that to a positive 2. So you just have to memorize these rules. You practice them, then you will remember them. So you have 4 thirds times 4 thirds. Top, top, bottom, bottom. What if we have negative 5 to the power negative 2? I did this problem. What if I have 1 over 10 to negative 2? We don't want to have negative exponent. What do I do with this? I move it to the top. It becomes positive 2. If I have 5 to the negative 2, I move it to the, I write it over 1. It becomes positive. If it's on the bottom, move it to the top. It becomes positive. And you have a 1 here, right? So that's what is happening. That's why I didn't write that 1. So if I have a 3 over 10 to the power minus 2, it becomes 3 times 10 to the power positive 2. So you move this, multiply it by the numerator, it becomes positive. And 10 to the power 2 is 100. There's this thing radical. What does radical means? It means, let me start with a simple example. It means what number do I multiply by itself? I get 36. 6 times 6 is 36, so the answer is 6. If I say what is the square root of 4? You say what number do I multiply by itself to get 4? The answer is 2. 2 times 2 is 4. So we call 2 is the root of square root of 4, or 6 is the root for square root of 36. So now that I have a fraction, I can look at it as a square root of 36 and a square root of 49, just like that. This rule holds if you have 4, let's say, times 9, you can look at it as a square root of 4, a square root of 9. But if you have addition here, don't write it as a square root of 4 plus a square root of 9. This is not correct. If you have multiplication, you could write it like that. If you have a division, you could give a radical to the top, a radical to the bottom. So this is okay, this is correct, this is incorrect. The square root of 36 is 6. The square root of 49 is 7. So the answer is 6 over 7. What if you have a square root of a negative number? When you have a negative number, the answer is undefined, because if I put negative 5 times negative 5, I get 25. I don't get negative. If I put positive 5, I get 5. So if I have a negative and negative, I get positive. But if I have a negative 25, that means one is negative, one is positive, so we don't have an answer for that. That's undefined. The square root of 1 is 1. The square root of 0 is 0, because 0 times 0 is 0. 1 times 1 is 1. But if you have a negative 1, the answer is undefined. How about if we have a situation like this one? So here, on the other problem, this one, this is called the square root. That means the root is 2. That means we want two numbers times itself to give me 25. And the numbers are 5 and 5. So the answer is 5. But when you have 3 here, that means you are looking for 3 numbers times itself to give you 27. And such a number is 3 times 3 times 3. And the answer is 3. How about if I say, what is third root of 8? What number do I multiply by itself 3 times to give me 8? The number is 2. 2 times 2 times 2 is 8, so the answer is 2. What if I have 16? And I don't have a number here, so that's the second root. So I write this as 4 times 4. So I have 2 4s, the answer is 4. Or if I have 36, because this is second root, I need 2 of them. 2 6s gives me 36, so the answer is 6. But if I have 64 and I have a 3, then I write it as 4 times 4 times 4, because 4 times 4 times 4 is 64, so the answer is 4. What if I have a negative number, such as negative 27? Is that possible? Because remember we said this is undefined. But is that also an undefined? Because this is the second root is undefined, but if it's a third root, it's not undefined. This is negative 3 times negative 3 times negative 3. It is possible to have 3 negative 3s, and that gives me negative 27. So the answer is just going to be negative 3. If I have third root of negative 8, that's possible, because I get negative 2, negative 2, negative 2. That's negative 8, so the answer is negative 2. What if I have 27 over 64 and I'm looking for the third root? 27 is made out of 3, 3, 3. 64 is made out of 4, 4, 4. I'm looking for third root. I don't write 64 as 8 and 8, because then I have only 2. I want to have 3 of the same thing, so I write 64 as 4, 4, 4. The answer to the top, I have 3 3s, comes out as 1 3, and the radical goes away. I have 3 4s, it comes out as 1 4. So the answer is 3/4. The last thing is very important, because later on you have to simplify things like that to get your answer. So I'm just going to do a couple. If you have a square root of 50, 50, that is a square root, so you want 2 of the same thing. 50 is made out of 5 and 10. 10 is made out of 5 and 2, so you can write 50 as 5 times 5 times 2. 25 times 2 is 50. So you have 2 5s, and you're looking for second root, because there's no number, so you're looking for doubles. Since you have 2 5s, it comes out as 1 5, but you have only 1 2, leave it alone. So let's practice. How about the square root of 12? 12 is made out of 3 and 4. 4 is 2 and 2. So you write 12 as 3, 2, and 2. Do you see you're looking for square root? So you have 2 2's. It comes out as 1, 2. And then the 3 stays under. What if you have, let's say, 18? 18 is made out of 3, 3, and 2. You have 2 3's. It comes out as 1, 3, and you have a square root of 2. Let's say one more. What if I have 15? 15 is 3 and 5. I don't have double of anything, so it stays the square root of 15. How about 8? 8 is made out of 3 2's. Only I can pull out 2 because it's a square root. So I pull out one of the 2's, and then the other 2 stays under.